Let us continue the discussion on periodic signals and aperiodic signals. So let us take another example. X of t is equal to 2 times cos 10t plus 1 minus sin 4t minus 1. So we will have to find the time period for the signal. So there are two components here, two terms here. One is a cosine term and the other one is a sine term. And for the cosine term, we are having the, let us call it as omega 1. The frequency, the angular frequency is 10 rads per second. So if I multiply 10 with t1, this should be equal to 2 pi. So t1 should be equal to 2 pi divided by 10. What about the other one? It is omega 2 is equal to 4 rads per second. So 4 times t2 is equal to 2 pi. So therefore t2 is equal to pi by 2. So we are having m times t1. So this condition will have to be satisfied. t2 should be equal to t. That is m and n should be integers. So m times 2 pi by 10. If I want to find out, my aim is to find t. That is the period of the signal. T is the period of this signal x of t. So when I am trying to find out, this is the approach. I have to multiply n with. So if I try to simplify this, it will be m times m by 5 is equal to n by 2. Now if both this should be equal, the m should definitely be equal to, this equation will be equal if and only if m is equal to 5 and n is equal to 2. If I substitute m is equal to 5 and n is equal to 2, the equation will the right LHS will match with the RHS. Okay, the right hand side and the left hand side will match. So if this is the solution for m and n for this equation to be satisfied. So therefore if I substitute 5 for m, it will be 5 by 5 and that will be equal to 2 by 2, which is equal to 1. So t, which will be equal to t. So the time period for the signal is 1 second. Okay, so let's try to solve another one more. Let x of t is equal to cos 4t plus sine 2 pi t. So omega 1 is equal to 4. So 4 times t1 is equal to 2 pi. So t1 is equal to 2 pi divided by 4, which is nothing but pi by 2 seconds. So the time period for the first term is pi by 2 seconds. So let us try to find out the time period for the second term, which is a sinusoidal term. Here in this case it is 2 pi. Okay, so it is 2 pi times t2 is equal to 2 pi. So t2 is 1 second. So in order to find t, the condition should be m times t1 should be equal to n times t2. Now here we are having m times pi by 2 is equal to n times 1. Now if you see, pi is an irrational number. Excuse me this. So pi is an irrational number. So m by n is equal to 2 by pi. M by n should be a rational quantity. A rational quantity in order for us to find the time period t. So if I want to find out the time period t for x of t, then the condition is m by n should be a rational number. But it is not possible to find, because since phi being irrational, it is not possible to find a value for m and value for n such that the quantity m by n will be a rational quantity. So therefore, the time period t does not exist for this signal. So it is a aperiodic signal. It should be understood that there are two terms here. The first term by itself is periodic. The second term by itself is periodic. But the sum of the two terms is not periodic. It is aperiodic. That is what we have proved just now. Okay. Likewise, we can go on solving many other problems also. But we will come back to this with more problems in future videos. But for now, we will try to continue with the classification. So the next type of classification that we are going to study is the symmetric and anti-symmetric classification. Symmetric, which is even, and anti-symmetric, which is otherwise called as odd signal. So the signal can be classified as symmetric or anti-symmetric signals. So to give an example, let me sketch a waveform. Let us say we are having a waveform something like this. Now you can very well notice that if I take any point, say let us say at a distance, some distance, let us say t0, in the forward direction, in the positive x direction, in the positive t direction, and again at the same time I take another point, negative t2 at this, in the reverse direction, in the negative direction, I notice that at both the points the magnitude is the same. Magnitude is equal to 1. Now in this case, let us say this x of t, and this, actually I can write it as a relation. I can say x of t is equal to x of negative t. When this condition is satisfied, then the signal, for a signal, if I have a signal, if I take the time reversal of the signal, and if the time reversed signal is equal to the signal itself, then such a signal is known as a symmetric or even signal. Okay. Or even, in other words, it is known as even. So this condition should satisfy for a signal to be symmetric or even signal. Okay. So let us try to understand what is meant by an antisymmetric signal. So I have a signal. Let us say I have something like this. Again, I take a point t1 at a distance t1 from the origin in the positive direction, and again I take same distance on the negative direction. When I try to find the amplitudes or the magnitude of the signal at these points, and if I find it is one amplitude is negative of the other amplitude, then such a signal is known as antisymmetric signal. So the condition for antisymmetric signal is x of t is equal to negative of time reversed signal. So what this means, I take the signal, I do the time reversal, and then I multiply with the negative one, and that negative one, so, and that quantity, if it is equal to the signal itself, then such a signal is known as a antisymmetric signal. Odd. So this is yet another classification of the signals. So any signal, if you take in, let us say if I have a signal x of t, any signal can be represented as a, will have an even part and an odd part. Some of the signals will, but the signal by itself will not be a even or an odd signal, but the signal can be decomposed into an even part and an odd part. So any signal can be thought of as a sum of even part of the signal and an odd part of the signal. So the even part of the signal can be written as x of t plus x of negative of t divided by 2. And the odd part of the signal can be written as x of t negative of x of negative t divided by 2. Okay. So in given a signal, if I am given a signal x of t, then I will be able to extract the even part by using this formula, and I will be able to extract the odd part of the signal by using the second formula. Let me call this as formula 1 and formula 2. And if I add these two, the first and the second equation, then I'll be getting the signal itself. Okay. So let us take some few examples. Let us try to find the, I have a signal x of t is equal to cos t plus sin t plus cos t sin t. I want to find the even part of the signal. The even part of the signal can be found as x of t plus x of negative of t plus divided by 2. So x of t is, I know what is x of t. X of t is cos of t plus sin t plus cos t sin t. X of negative t is x of negative of t plus sin negative of t plus cos negative of t sin negative of t. This I can simplify as cos t minus sin t. This can be simplified as minus sin t cos t. So if the even part of the signal is, I have to add up, so 1, let me call this as 2, I have to add up 1 plus 2. If I add up 1 plus 2, I get cos t divided by 2, which is nothing but cos t. And even part of the signal, I have to add up these two. Okay, the even part of the signal is this 1 minus 2 divided by 2. When I do that, I end up getting sin t plus cos t sin t. So this is the result. Okay, let me take another one. This time I will take the discrete. Let me take the discrete sequence and try to find out the odd and the even part. Minus 1 and 3. So this sample is at 0, at n is equal to 0. So x of n is equal to minus 2 minus 2 1 comma 2 minus 1 3. So x of negative of n is nothing but, this will remain where it is, but this one will change. These two will actually interchange their positions. Again, then these two will also interchange their positions. So it will become like this. So x even part of n is that I have to add up these two and then divide it by half. sorry, divided by 2. So the first one will be half, second one will be 0, the third one will be 2, fourth one will be 0, fifth one will be again half. So this is the, and this sample will be at n is equal to 0. So this is the even part. Again, you can get the odd part of this. Oh, sorry, this one is the odd. Oh, okay. Okay, we look at the odd part. The odd part of the signal is minus 5 by 2, then it is 1, then it is 0, then it is minus 1, then we have 5 by 2. So this will be the odd part of the sample sequence. We will try to do some more examples. Okay. Let us try to find the even and odd components of the following signal. X of t is equal to sine t plus 2 times cos t, sorry, 2 times sine t. You can add up these two and say 3 times sine t plus 2 square t cos t. So x of negative of t will be negative of sine t minus negative of 2 sine t plus 2 times sine square t plus cos square t. So the even part of the signal is I have to just add up these two. When I add up these two, these two terms will get cancelled out, and finally I will end up getting positive. So odd part of the signal is sine t plus 2 sine t. So let's take one more. This time x of n, discrete time sequence. X of n is equal to 1, 0, minus 1, 2, 3. Now I know minus n is nothing but, okay, this will be at 0. So it will be 3, 2, minus 1, 0 and 1. So I have to add up these two. When I add up these two, I end up getting 3 by 2. This is the even part of this. This again is 1 by 2. Oh, sorry, 1. This one is 1. And this one is negative 1 by 2. Then it is 0. Then it is 1. Then it is again 0, then it is negative half, then it is 1, and finally it is 3 by 2. So this is your even part of the sample. So if I want to find the odd, it will be minus here, it will be plus, it will be 0, then it will be again 0, again 0, then it will be minus half, 1 and 3 by 2. So this will be the, so if I add up all this, I should be getting back this. When I add these two, that is the even part and the odd part, I should get the, if I add up these two, I should be getting, that should be equal to x of 1. That is a check, that's how you validate the answers. So far we have covered different classifications. The first one being the continuous time and discrete time. The signal may be classified as the continuous time and discrete time. Then this deterministic and random signals. Then we saw the periodic and aperiodic signals. And then now we have seen what is meant by odd signal and an even signal. So these are some of the classifications so far we have seen. So the next classification that we are going to see is energy signal and power signals. So the signals may be classified as energy signal and power signal. Now if I have a signal, let us say I'm having a signal x of t or x of n. If it is continuous time signal, it is x of t. If it is discrete time signal, it is x of n. Now a signal is said to be an energy signal if the following expression is evaluated. Limit t integral of negative t to positive t x of t, I have to take the magnitude square dt, and this expression, if this integral, when it is evaluated, it should result in a finite quantity, so it should be less than infinity. And then in that case I can say it is an energy signal. So this is in the case of continuous time, where t is the time period. Okay, t is the period of the signal. Similarly, a signal can be considered to be a power signal. I'll write the integral. Okay, we'll continue on the next video. Thanks.